Hello, this is Jim Keener, Certified College Planner. I'm going to give you a quick tour of the ePrep SAT Level 1, Level 2 Math Combo course. Basically, it starts with the homeroom, and on the left you have the account options, and you can look at our college test prep video that explains how all this works. Up at the upper right, you'll see this is where, if you have more than one courses, this is where you select your course. So we're going to go ahead and select the math course. And then we're going to the exam room. Now here in the exam room is where your tests are. And actually, if you want to download the test, you can click here and it will take you to the test. So for example, Math Level 2, Test 1, Math Level 2, Test 2, Test 3, etc. You download the answer sheet and then you take the test offline. And then what you do is you go back into the exam room and you select the test you are going to take. For example, let's just go here to Math Level 2, Test 3. And this is actually where you review. It's loading the exam. And basically here is, these are where you complete your answers. Tells you whether they're right or wrong. Now, listen, don't laugh too hard. I totally guessed on this stuff, so I'm a little bit smarter than that. But anyway, so what we're going to do is watch a sample here of one of the questions. For example, we'll just take question 8. I apologize for the video. It's not quite as loud. The actual test course, the audio is much better. But this will give you an example of how this works. And what you do is you go down through here and you review the ones that you missed to start with. Then you can go back and review the ones you got correct depending on your time. So let's just play question 8 so you can see how this works.
What is the value of the square root of x if x is equal to the square root of 20 squared minus 12 squared? Well, let's work on this first. Let's figure out what this equals. So the square root, 20 squared, is equal to 400 minus 12 squared is equal to 144. So if over on the side here, you do this 400 minus the 144, okay, you're going to have to borrow. You're going to get 6 here, 5 here, and a 2 here. So you're going to have 256. Now, the square root of 256 is equal to 16. Alright? But don't come up here and pick this answer choice, because this is what x is equal to. X was equal to 400 minus the square root of 400 minus 144. So x is equal to the square root of 256, which is 16. The question was, what is the square root of x? So now that we figured out what x is, we're going to need to take the square root of that to get our final answer. So the square root of 16 is 4. I would pick A with confidence and quickly move on to the next question.
Okay, we'll go ahead and play another one just so you can see a little bit more.
If 5x plus 15 equals k over 3 times x plus 3 for all x, then k equals what? So let's take this equation right here. Let's just solve it for k and see what happens. So the first thing I would do is I would divide this side by x plus 3, not 2, x plus 3, and then I would divide this side by x plus 3. And over here, the x plus 3's would cancel, they're gone. And now what I would do is I'd take a closer look at this, and I can factor 5 out of here. So if I factor 5 out of this numerator, I'm left with an x plus 3. And to check, 5 times x is 5x, and 5 times 3 is 15. So I factored it correctly, and now I'm going to divide it by this x plus 3. And I'm still left with a k over 3 here, and you can see that the x plus 3's cancel out. And to solve for k, I would multiply this side by 3, so the 3's cancel, and I would multiply this side by 3. My final answer would be k is equal to 15. I see that e is 15. I would pick it quickly with confidence
Okay, and here's one more.
The graph of the rational function f, where f of x equals 3x plus 3 divided by x squared minus x minus 2, has vertical asymptotes at x equals, and here are your choices, okay? So when you look for vertical asymptotes, right, you want to focus on what x values make the denominator 0. Those are going to be points that are undefined, right? They're not in the domain of the function. So I'm going to take a look at this, and I'm very interested in when is x squared minus x minus 2, when is it equal to 0, right? So I'm going to factor this thing, and if I factor it, I'm going to have an x and an x, a 2 and a 1, and this one will have to be negative, and this one will have to be positive in order to get the negative x in the middle, because this middle term here, the negative x, is the combination of these inner terms and the outer terms. And you combine them, there's the negative x. Okay, so I know I did it right. So, normally I would say, okay, my vertical asymptotes are x is equal to 2 and x is equal to negative 1, because these two values are the solution here. But you have to watch out. You have to make sure that these are truly vertical asymptotes and not removable points of discontinuity. This is how you can tell the difference between a vertical asymptote and a removable point of discontinuity, okay? If you take this original function again, right, and let's take it over here and let's simplify the top. If I factored out a 3, I would be left with x plus 1. And then if I factor the denominator, like I did here, I would have x minus 2 and an x plus 1. And you can see that the x plus 1's cancel. So if you have an issue in the denominator that can cancel away with some algebra, that means that x is equal to negative 1 was not a vertical asymptote. It was a hole in the graph. It was a removable point of discontinuity, okay? So when you can cancel out one of the issues using algebra, it is not a vertical asymptote. It's a hole in the graph. It's a removable point of discontinuity. This is the only vertical asymptote, the one at x is equal to 2. So I would pick C with confidence and move on to the next question.
Okay, thank you for your time, and please let us know if you want to get up to speed on your math.